All right, our next topic is going to be Lewis structures. So make sure you copy down this chart in your notes, and then we're going to fill it out. All right, so group 14. We're going to draw the electron dot diagram. We're going to use carbon as our example. We know carbon has 4 valence electrons. We're going to draw 4 dots. Remember, valence electrons are the numbers at the top of the column, not the charge, the number at the top, like 14, 15, 16, 17, and then we drop the 1. Group 15, we're going to use nitrogen. It's going to have 5. Group 16 is oxygen. Group 17 is fluorine with 7. And then hydrogen has 1. All right, now number of lone pairs. So a lone pair of electrons is going to be electrons in a pair. These electrons cannot bond, so they're not going to participate in bonding when we draw our Lewis structures. So carbon has no lone pairs. Nitrogen, so you see this pair together, that's what we refer to as a lone pair. So it's going to have 1. Oxygen has 2. Fluorine's going to have 3. And hydrogen has none. Now, number of single electrons, so that's going to be 1 single dot. These can participate in bonding. So carbon has 4 single dots. Nitrogen is going to have 1, 2, 3 single dots. Oxygen has 2, fluorine has 1, and hydrogen has 1. So these single dots allow us to bond, okay? So each dot can participate in 1 bond. So carbon has 4 dots, it could make 4 single bonds. Nitrogen has 3 dots, it can make 3 singles. Oxygen can make 2 singles. Fluorine can make 1. Hydrogen can make 1. Now, number of double bonds. If you want to make a double bond, you need 2 single electrons available in order to do that. So carbon can make a total of 2 double bonds if it wanted to, because it could have 2 of these enter into one, and then these other 2 enter into another double bond. Nitrogen could only make 1 double bond. You would need 4 single electrons to make 2. Oxygen can only make 1. Fluorine cannot make any double bonds. It only has 1 single electron available for bonding, and hydrogen cannot make a double bond. Triple bonds, so I need 3 single electrons available for a triple. So carbon can make 1 triple bond, nitrogen can make a triple bond, oxygen cannot, fluorine cannot, hydrogen cannot. Now, however many single electrons an element has, that how many bonds it must make in a picture, okay? So anything from group 14 has to make 4 bonds, anything from group 15, 3 bonds, anything from group 16 has to make 2, 17, 1, and hydrogen 1. So kind of this information is going to help us draw our Lewis structures, okay? So rules for Lewis structures. So make sure you copy all of this information down. So when I'm saying this word Lewis structure, I mean things like if you've ever seen something drawn like this. So that we have like lines, and then we're connecting to other elements. This would be a Lewis structure. So the lines in a Lewis structure will be the bonds, and then sometimes there's going to be dots, and those will be electrons. So when we're drawing Lewis structures, we need to add up the total number of valence electrons, and there has to be that many in the picture. Every atom must have an octet around it except oxygen. So remember, octet means 8. Hydrogen only needs 2 electrons to be filled. And then the number of bonds should correspond to the group. So anything in group 14, every time you look at the picture, should have 4 bonds and no lone pairs. Group 15 should always have 3 bonds and 1 lone pair. Group 16, 2 bonds and 2 lone pairs. Group 17, 1 bond and 3 lone pairs. Hydrogen, 1 bond and no lone pairs. These are very important. You need to make sure you copy this down. All right, now let's try an example here. So CH4. First thing we're going to do is add up our valence electrons. So carbon's in group 14, it has 4 valence electrons. Hydrogen has 1 valence, I have 4 hydrogens, so I have to multiply that number by 4. 1 times 4 is 4. Now, carbon brings 4 valence, all the hydrogen bring another 4, we got to add those numbers up. So in my picture, I need 8 electrons in my final picture I'm going to draw. So some kind of like helpful hints here. The element by itself is usually in the middle. Follow the chart. I'm sorry, I should say follow the rules. So by the rules, I mean at the end of that last slide, I had group 14 making 4 bonds, no lone pairs. You have to follow those rules for your picture. So carbon is by itself, so let's put it in the center. Now, carbon is in group 14. Because carbon is in group 14, it should make 4 bonds, and it should have no lone pairs. Now, it has to make 4 bonds, and it has to bond to 4 things. That should tell you it's going to do 4 single bonds. And then each H is going to be connected at the end. Now, the rule for H was 1 bond, no lone pairs. Okay, now, each element needs 8 electrons around it. So you have to count everything that's touching the carbon. So this bond is touching the carbon, that's 2 electrons. This one, 2 electrons. This bond, 2 electrons. This bond, 2 electrons. Remember, a single bond has 2 electrons in it. So all of these are touching carbon, 2, 4, 6, 8. Carbon has 8 valence, that is good. Each hydrogen only needs 2. And each of these hydrogens has 1 line connected to it, which is 2 electrons. That's good. Finally, my picture needs 8 total electrons. 2, 4, 6, 8. My picture is good. So this would be my final picture, and this is the Lewis structure for CH4. So there's lots of checks here. You're going to use that group 14, 4 bonds, no lone pairs, so use that. You got to count up the total valence electrons in the picture. Everything should have 8 electrons around it except hydrogen that only needs 2. All right, NF3. So count up our valence. N is 5. Each fluorine brings 7. I have 3 of them. 7 times 3 is 21. 5 plus 21 equals 26 electrons. This number should always be even. If you for some reason get an odd number, something has gone wrong. All right, now, the element by itself is nitrogen, so I'm going to put that in the center. It's in group 15. That tells me 3 bonds, 1 lone pair. Fluorine, group 17. 1 bond, 3 lone pairs. Okay. Now, I don't know how these 3 fluorines are going to be, so just whatever, just draw them somewhere. So my picture allows for 1 nitrogen and 3 fluorines. So I need 3 bonds. 1, 2, 3. All right, that seems plausible. Now I need 1 lone pair on the nitrogen. Lone pairs need to be by themselves. You can't draw them next to a bond. So something like this is no good. Don't draw it like that. Now each fluorine needs 1 bond, which they have, but they also each need 3 lone pairs. Whew. All right. So checks. 26 electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Whew, 26 electrons. Nitrogen has 2, 4, 6, 8 around it. Good. Each fluorine has 2, 4, 6, 8 around it. Excellent. So my final picture, and you don't have to redraw this, I just have a bunch of numbers around there, so I just want to make it clear what the final picture is. That is your final picture for NF3. All right, HCl, another example. The only way to get good at these is to do the practice. There's no like special procedure I can tell you to do. There's no special like math equation. You just have to do the practice and follow the chart. So hydrogen's gonna bring 1 electron. Chlorine's gonna bring 7. 1 plus 7 is 8 electrons in the picture. Now there's only 2 things, HCl, that's it. So you have to, there's not really a center here because there's only 2 elements. So how are you gonna combine them? Always try to start with a single bond. That's your best bet. Okay, single bond. Hydrogen we know makes 1 single, no lone pairs. I'm just gonna put LP for lone pairs. Chlorine is in group 17. It should have 1 bond, 3 lone pairs. Well, the chlorine has 1 bond, let's add on the 3 lone pairs. All right, check your 8 electrons. 2, 4, 6, 8. Our picture has 8 electrons. The chlorine has 8, hydrogen has 2. This picture is good. All right, SiO2. Silicon, 4 electrons. Each oxygen brings 6 times 2 is 12. Add them up. Okay. Silicon, group 14. 4 bonds, no lone pairs. Oxygen, group 16. 2 bonds, 2 lone pairs. And I'm just getting that from that little list I gave you, okay? I'm just rewriting it for myself. All right, so in my picture, I'm allowed 1 silicon and 2 oxygen, that's it. So I'm just gonna draw 2 oxygen somewhere. 1, 2. Okay, so let's put our single bonds in. All right, now, silicon's in group 14. It needs 4 bonds. I only drew 2 bonds, so that's not good. Now, you cannot do this. There's nothing to connect to. I can't have more than 2 oxygens, so that's not a possibility. So when that happens, that means you maybe need some doubles or triples in there. So let's see, if I put a double bond here and a double bond here, now silicon is making 4 bonds. Excellent. Let's check the oxygen. The oxygen on the right has 2 bonds, but now I need to add on 2 lone pairs. Same thing for this oxygen. Okay, now check. 16 electrons. 2, 4, 6, 8, 10, 12, 14, 16. Good. Silicon. 2, 4, 6, 8 is good. Oxygen, 2, 4, 6, 8. 2, 4, 6, 8. Everything's good. All right, so these are Lewis structures. Remember, you're only allowed what's in the formula. So you can't have more silicon than 1 because I only have 1 there. You can't have more than 2 oxygen, it's O2. So draw those elements in. Element that's by itself goes in the center. Check what group it's in, and that will tell you the number of bonds, number of lone pairs. Everything needs 8 electrons except hydrogen only needs 2. And then check your total valence number from the picture.